These are the multiplication rules for probability, and these have to do with AND questions. If you watched the other video where we talked about the addition rules, those were OR questions. So whenever we wanted to know if something happened or something else happened, that was addition. Whenever we want to know when two things happened together, not just one or the other, but both, that's where the multiplication rules for probability come in. The first concept we need to think about is independent. Two events are independent if they do not affect one another. Now the opposite of that would be dependent. Two events are dependent if they do affect each other. So these are the concepts we need to consider because this will affect how we approach the problem, whether the two events are independent or dependent. Now here we see how to find the probability of two independent events. If two events have no effect on each other, one happening or not happening has no effect on whether the other one happens, then the probability of A and B happening is just the probability of A times the probability of B. So our first example, what would be the probability of rolling two 4s? So here's what you need to imagine. You have one die, you roll it one time, you pick it up and you roll it again. Well, the first roll should have absolutely no effect on the second roll. It's random every time. So rolling the die one time has no effect on you rolling a die the second time, so these two events are independent. So we need to figure out the probability of rolling a 4 and rolling another 4. That will be the probability of rolling a 4 times the probability of rolling a 4. Well, if you just have a normal 6-sided die, the probability of that would be 1 out of 6. And the probability of rolling a 4 again would still just be 1 out of 6. One roll does not affect the other. So the probability of rolling a 4 twice in a row would be 1 out of 36. 1/6 times 1/6. Okay, now let's think back to our deck of cards. What is the probability of picking a face card, replacing it in the deck, and then picking an ace? So again, just imagine you've got a deck of cards. You randomly pick a card, look at it, remember what it is, then you put the card back and you randomly pick another card. You can shuffle in the middle if you want, if that makes it better for you. But the point is, since you returned that original card to the deck, it's random all over again. You've still got 52 cards to pick from. Your first pick should have no effect on your second pick. So these are independent events as well. Since you replace the card in the deck, the second pick has no effect on, or the first pick has no effect on the second pick, and the two events are independent. So the probability of choosing a face card and then choosing an ace is equal to the probability of a face card times the probability of an ace. The probability of a face card is 12 out of 52. There's 4 queens, 4 kings, and 4 jacks. So that's 12 cards. And we multiply that by the probability of it getting an ace, which would just be 4 out of 52. Again, I'm going to let my calculator help me out on this one. So 12 out of 52 times 4 out of 52. Change it to a fraction. We get 3 out of 169. So the probability of drawing a face card, putting it back in the deck, and then picking an ace after that would be 3 out of 169. Okay, next example. The probability of a minor getting black lung is 5 out of 11, and his chance of getting arthritis is 1 out of 5. If these don't affect each other, what is the probability of not getting black lung but getting arthritis? So there's several things going on here. First of all, it should make pretty good sense to you that getting black lung is not going to necessarily affect arthritis. Inflammation of the joints is not related to lung cancer or black lung. So these are independent events. One does not cause or affect the other. So that means we can use the simple multiplication we have here. So we want to know the probability of no black lung and arthritis. And that's going to be the same as the probability of no black lung times the probability of arthritis. And you have to think carefully here since they're asking the probability of not black lung. Well, if the probability of getting black lung is 5 chances out of 11, then how many chances out of 11 would it be to not get black lung? It would have to add up to 11, so 5 plus 6 equals 11. So if the probability of getting black lung is 5 out of 11, the probability of not getting black lung is 6 out of 11. You can always solve this by doing one minus the other. So for example, if I want to know the probability of not getting black lung, that's equal to 1 minus the probability of getting black lung. This is true anytime you're doing a not. Probability of not doing something or not getting something is 1 minus the probability of getting it or having it. So we get 1 minus 5 over 11, and that is 6 over 11. So that's how we get the probability of not getting black lung. Now we multiply that by the probability of getting arthritis, which is 1/5. So we get 6 out of 55 as our probability. So what if the two events are dependent? What if they do affect each other? Well, here's where the problems get a little bit trickier, but usually if you can visualize it, kind of reason through it, it'll make sense to you. So if two things are dependent, they do affect each other, then the probability of A and B is the probability of A times the probability of B following A. And this is also written like this sometimes, the probability of A times the probability of B given A. So they put just a straight line in between B and A instead of saying following or given. And you'll see how this works as we go through some examples. So Tasha has 3 rock, 2 country, and 4 jazz CDs in her car. What is the probability of her picking 2 rock CDs? So she's going into her car and randomly picking a disc. She picks one, it's a rock CD, and then she picks the second one, and it's a rock CD. So these events do affect each other, because when she goes in for the first time and chooses a CD, there's a total of 9 CDs, 3 rock, 2 country, and 4 jazz. But as soon as she picks one and goes back to pick the second one, there are no longer 9 CDs. There's only 8. So she has affected the probability of that second pick. So the first pick did affect the second pick because it changes the odds once you remove one of the CDs from the car. So we need to think, what's the probability of picking a rock CD the first time, and then what's the probability of picking a rock CD second? So first of all, she starts with 9 CDs, and 3 of them are rock. So the probability of getting a rock CD the first time would be 3 out of 9. But now she's picked one, so there's not one of these rock albums is gone. Now there's just 2 rock albums left in her car because she's already picked one. So now there are 2 rock, 2 country, and 4 jazz. So now there are 8 CDs and only 2 of them that are left are rock. So I need to multiply by 2 times 8 for the probability of that second CD she picks also being rock, because I'm taking into account that A has already happened and seeing what the probability of B happening would be. I multiply these together, 3/9 times 2/8. It gives me 1/12. So the probability of B following A is just, okay, now that A has happened, what would the probability of B be? So what's the probability of drawing a 7 and then drawing a face card if we do not replace the card? Earlier we had one where we did replace the card. So again, try to visualize a deck of cards. If you draw a card and put it right back, then you haven't changed anything once you pick a second card. You still have 52, all the same things you had when you started with. But if I pick one card and hold it in my hand and then go back for a second card, then the probabilities have all changed, because since I kept that first card, there's now only 51 cards in the deck when I go back to pick the second card. So what is the probability of drawing a 7 and then drawing a face card if we do not replace the card? So first, if we want to draw a 7, the probability of drawing a 7 would be 4 out of 52. So we draw a 7. There's now only 51 cards in the deck, and there's a 7 missing. And then drawing a face card. Well, the face cards are still all there because we drew a 7 the first time, so that hasn't affected the number of face cards. There's still 12 face cards. However, there's only 51 of them, 51 total, in the deck. So if I pick a 7 first, the chances are 4 out of 52 times 12 out of 51, because there's one less card when I go back to choose again. So 4 over 52 times 12 over 51. We get 4 out of 221 is our probability.